All right, so it says a student and the wax skis she is wearing have a combined weight of 850 newtons. The skier travels down a snow-covered hill and then glides to the east across a snow-covered horizontal surface. Okay, so there's a lot of information packed in there. Okay, so there's this student. She's wearing wax skis. They have a combined weight of the following 850 newtons. She is traveling down a snow-covered hill, and then she glides eastwards across a snow-covered horizontal surface. Okay. Again, I apologize for the coughing. Determine the magnitude of the normal force exerted by the snow on the skis as the skier glides across the horizontal surface. Okay, so I'm going to draw a diagram right here, a little free body diagram. Okay. They don't tell us if she's, traveling at a constant velocity. They don't tell us if she's at rest. Well, clearly we know she's moving, so she can't be at rest. We don't know if she's accelerating. We don't know that information. What we do know is the following. She is moving with some velocity towards the right, okay, because that is eastward. So if you forget your direction, never eat sour watermelons, okay? So now let's draw a free body diagram. The force that always pulls down is the force of gravity. The force that always pushes up on us is the normal force, okay? So if she is moving to the right, you know she's going to have some sort of friction here. They did not tell us this was a frictionless surface. And again, they didn't say she's moving at constant velocity, so it is kind of rightfully for us to assume that she is accelerating. So I'm going to put my FA going like this, okay? Just keep that in mind. So that's my free body diagram right there. So now they're saying determine the normal force, okay? The normal force, if you look at this diagram that I drew, we can say, we can say that the normal force, Fn, is actually equal to my force of gravity. So how is that helpful for us still? Well, if you go back into the reading, it says the following. A student and the wax skis she is wearing have a combined weight of 850 newtons. So they basically tell you right there the information. That's the answer. So you're saying that my normal force is equal to my force of gravity, and that is equal to 850 newtons. So this would really be a 1-point question because they're going to ask you to pull it out right from the reading. Okay, but now number 3 gets a little trickier. It says calculate the magnitude of the force of friction acting on the skis as the skier glides across the snow-covered horizontal surface. Okay, she does have skis on. They are wax skis specifically. So I want to write that down, right? So they're saying wax skis on snow, and she's moving, right? Because she's gliding. So that is very specific information. So where do you have to look? On page 1, approximate coefficients of friction. You would not be looking at the static because she's, excuse me, she's not standing still, or she's not being still at rest. She is, in fact, gliding down that mountain. So you are going to use the kinetic coefficient of friction. Okay, so let's write out our givens and unknowns here. So we said that my normal force is equal to 850 newtons, okay, because normal force and weight are the same thing. We then know that my mu k, right, so mu is the coefficient of kinetic friction, or coefficient of friction, and then by me putting the subscript k, I'm saying that it's kinetic, not static. So we put 0.05. My unknown is the force of friction. If you go to your reference table, there's going to be a formula that is available to you. Okay, it's going to have friction, mu, and Fn. So it looks like the following. Ff equals mu Fn. Now we're just going to plug everything in. So we don't know what Ff is because that's the thing we're solving for. Mu is 0.05, and my normal force is 850 newtons. Again, when you are doing this, since it's a short answer, you definitely want to make sure that you have units. And my force of friction is the following. So 0.05 times 850. And you should get a value of 42.5 newtons. Okay? So let's take a look at this following example. The diagram below represents a 4 Newton force applied to a 0.2 kilogram copper block sliding to the right on a horizontal steel table. Determine the weight of the block. Okay, so there's a lot of information here. So we have a 4 Newton force applied to a 0.2 kilogram copper block that is sliding to the right on a horizontal steel table. That's really important for us. Okay, first question, what is the weight of the block? So if you recall that mass is not the same thing as weight, okay, because weight is a force and mass is not. So how we go about finding that? Well, let's list our given. So we know unknown for sure is the force of gravity, which is weight. So my givens here, they gave me a mass of 0.2 kilograms. Okay. My equation, if you go to the back of the page, you are going to see the force of gravity written a little different here. You're going to see it as G equals Fg over M. In our class, we always just said, hey, Fg equals Miss Glickman, which is M times G. Either way, if you just put the 1 here, you do cross multiplication and you actually end up with that form right there. So now let's substitute. We don't know the force of gravity yet. That's the thing we're solving for. 0.2 kilograms. What's my G? Well, that's known as the acceleration due to gravity. And we say that's 9.81 meters per second squared. Notice that I dropped the minus sign because I'm not trying to say that my weight is going downwards. I'm just trying to say like what the actual magnitude is. So then you would just calculate this. So you would do 0.2 times 9.81 and you would get 1.962 newtons for your weight. Okay. Then it says calculate the magnitude of the force of friction moving along the block that is moving. So if we wanted to make this a free body diagram, you would say that this is my normal force. This is my force of gravity. You know that if there's an applied force, it's moving in this direction. Friction goes in the opposite direction. So you'd have some sort of frictional force, excuse me, over there. And then this would be your applied force. Okay. I'm sorry. I really am sorry for coughing so hard in the microphone. So, what you would need to do here, right? Because they're not saying they want to find the net force, they want to find the force of friction. You're going to list out your givens. So, your first given would be that your normal force or your force of gravity, right? Because they are the same thing. 1.962 newtons. You have a copper block sliding on a steel table, okay? That's really important. So it's very, very specific. So copper moving on steel. So I go to my reference table and I say, where can I find these very specific materials? That is on page 1, approximate coefficients of friction, okay? You're going to be using kinetic here, not static, because again, it is moving on steel. So you're going to literally go down to almost the bottom. It says copper on steel. Kinetic would be 0.36. Okay, so my mu k equals 0.36. Again, that is a naked number. It does not require units. My unknown is my force of friction. My equation, if you look on page 6, would be FF equals mu Fn. You're going to substitute. We don't know what the frictional force is. That is the thing we're solving for. Mu is 0.36, came from our reference table. Our normal force is 1.962 newtons. Again, you do not want to lose any points for not having units. And you should get an answer of the following. So my frictional force should be equal to 0.36, times 1.962. And you should get an answer of 0.71 newtons. Okay, that is a very small friction force value, okay? But it makes sense because you have such a small normal force, all right?